In section 4.5, we're going to look at exponential growth. And we've actually already seen growth models. We did this in chapter 1. So I want to remind you what a growth model looks like. We have our starting value, or our initial value, and then we multiply by 1 plus the growth rate, and that is raised to the number of years. So as an example, if I started with $800 and this grew at a rate of 2%, that would be 1.02. That's a 2% growth rate. Why? Because 2% as a decimal is 0.02. And if I wanted to see what would be the value in 15 years, I would raise that to the 15th power. So I wanted to remind you that you've already seen this, but now we're actually going to give it the phrase exponential growth. And we can see some exponential growth here with the purple graph. All right, so we'll get a lot of practice reading graphs here. As we begin, let's look at the savings plan for Joe. All right, so Joe is 30 years old. Let's look at his age here. He's starting at 30. And he has a steady job making $30,000 a year, and he gets an annual raise of 4%. So here's his salary. His salary is the green. So his salary is going up at 4% every year until you can see he gets into his late 60s, because here's 65. So between 65 and 70, he stops working. Looking ahead to the future, Joe commits to saving 12% of his earnings every year. Okay, so if he saves 12%, that means he's living on, what is 100 minus 12? 88%. He's living on 88% of his salary if he's saving 12% every year. And so that's what he has for his expenses. So that's what we have here with the gold. This gold part of the graph is 88% of what he's making. That's what he's spending on his living expenses. He chooses a fixed fund investment that returns 9% annually. The following graph shows Joe's earnings, that's the green bar, going up at 4%. It also shows the amount of money he spends, that's the gold. He always spends less than he makes because he's putting some money away. And this purple bar, or these purple dots, is the amount of money that is generated by the interest on his investment. So the purple curve isn't the amount he's saved. No, it is the amount of interest being earned every year in this 9% fund. All right, so let's look at this graph. We'll continue to look at this graph. We're going to look at this graph a lot. The investment income graph displays the true magic of exponential growth. The income is limited when Joe's a young guy. He doesn't have that much income. But as he gets closer to thinking about retirement, the income takes off. Like, look, he's up here earning $120,000, $130,000 a year. Notice that age 65, something awesome happens. The income that Joe is making from his investments, see this purple line? The income that he's making from his investments is more than his living expense. So right here, the income from, or the interest, the income he's making from his investments is more than he's spending. At that point, right here, he would be able to retire and just live off the income from his investments without having to work. And that is known as the crossover point. The crossover point is the point where the money that your investments are making covers your living expenses. And then you can retire comfortably. All right, so use this information to answer questions 1 through 5. How much money is Joe earning when he's 30? Where we were told in the problem, he's earning $30,000 a year. I mean, we can see that on the graph also. Question number 2. How much money is he allowing himself to spend when he's 30? If he's saving 12%, he's spending 88% of 30,000. 88% of 30,000, he is spending 26,400 per year. All right, and so we can see that here. That's the gold or the orange line. This is how much he's making. This is how much he's spending. Question number 3. How much is Joe earning? Now let's look when he's 35. So if we look at our graph, we'll have to go back and forth here. Here's 35. How much is he making when he's 35? All right. We started at 30, and we were told he gets a 4% increase. So that's why it's 1.04, and that's 5 years since the starting point. This is what he's going to be making when he's 35. So that is $36,499.59 per year. How much will he earn when he's 35? Show the calculation based on the annual relative growth rate. There's 4%. Then describe whether or not your answer seems to be correct based on the graph. Does 36,000 look about right there? Yeah, if that's 20 and that's 40, it's gone up to about 36,000. Yes, it looks good. Seems right. How much money is Joe allowing himself to spend when he's 35? So he's going to spend 88% of what he's making. So he's only going to, even though he's making 36, almost 500, he's going to spend 32,119 and 64. 88% of what he's making when he's 35. And does that seem right? Let's look at the gold at 35. Yeah, that looks about right. Yes, it looks right. Okay, so carefully explain the meaning of the crossover point. So, the money you invest earns interest. And then the money you continue to invest plus the interest earns more interest. So at some point, the amount of interest earned every year is greater than your expenses. And that's the crossover point. So you're living on the interest that's being generated. You're not even going into the money that you've put away. It's just the interest that gets generated is going to be paying for your expenses. All right. Now let's go back to the graph. We've got several more questions here. How much is Joe earning when he's 60? How much is Joe earning when he's 60? All right, well, we'll use the calculation, but let's also look at the graph. Earning looks to be about 100,000. But he started at 30,000. His salary grows, increases 4% a year. So when he's 60, that's 30 years after starting at age 30. I know there's a lot of 30s in that calculation, but he started at 30,000, got a 4% raise every year for 30 years. When you put that in your calculator, when he's 60 years old, his salary is $97,301.93. All right, how much is he allowing himself to spend? He's still saving 12%. So he's still spending 88% for his housing expense or for his living expenses. So living on 88%, he's spending $85,625.70. And does that kind of look right? Let's look at 60. Yeah, that's about 97, really close to 100. Let's look here. Oh yeah, that's down a lot further. That's much closer to 80,000 than it is 100,000. So that definitely looks right on our graph as well. How much is Joe earning from his investments at age 60? All right, so let's just look at the graph. Let's just look at the graph here. At age 60, he's earning, I don't know, maybe 65,000. If this line is 60 and this line is 80, should we estimate? $65,000 a year. So when he's 60, he spends 85,000 plus on his expenses. His investments are returning 65,000. So he's not totally covering his investments yet at age 60. But he still has a good retirement plan going here. Question 9. Write a function in the form f of x equals expression, where the expression describes the amount Joe earns x years after age 30. My function f uses the variable x. F of x equals, he started at 30,000. We've been using this already in our example. He started at 30,000. He has a growth rate of 4%, and that's going to be the value x years from age 30. So we've already done this one. Number 10, find how much Joe earns at age 60. When x is 60, 30,000, 1.04. I'm sorry, when x is 30. At age 60, x is the number of years since he was 30, or the number of years he's been investing. So that was the 97,301.93. Write a function in the form, number 11, write a function in the form f of x equals expression where the expression describes the amount Joe spends. The function f with the variable x is 88% times how much he makes. This is his salary, and he always spends 88% of it. So use your answer to find how much Joe spends at age 60. We've actually already done that. 30 years after working, 0.88 times 30,000, 1.04 raised to the 30. That's 88% of the 30,000. That was our 85,625.69. And that's also what our graph showed.